In this video, we're going to talk about exponential functions and their applications. The most common application for exponential functions would be savings accounts, where you earn interest on those savings accounts for leaving it in there for a certain number of years and compound it at certain times throughout that year. So we're going to take a look at what that looks like. So I look at my first question. I'm going to invest $2,000 at a rate of 4.3 compounded quarterly for 5 years. So I'm going to take all of those pieces of information, plug that into a formula, and then figure out how much will I end up with at the very end. All right. And if you remember, we're going to use this formula here. We have A sub t, which is going to be our final amount. A sub o is our initial amount. The r is our rate. And the end value is how many times it's compounded throughout the year, and t is going to be my number of years. So all I'm going to do is plug in that information, right? So I have 2,000 was how much I started with. And I've got 1 plus my rate, which my rate is 4.3%. I don't want it as a percent, I want it as a decimal, so I'm going to rewrite that as 0.043. Simply just move that decimal 2 to the left. Over n, n comes from this right here, quarterly, which means 4 times per year. So I've got 4 there, and then I have 4 times the number of years, which is 5. Now we need to notice that everything here on the right side is now a value. I have no unknowns over there, so I can simply type that into a calculator and come up with a number that will give me the amount I have after 5 years while compounding it quarterly at a rate of 4.3% interest. And if I type that in my calculator, I know A of t, or my y value, or my ending amount, will come out to roughly $2,476.88. Okay? All right, so in this question, we have another interest rate question. So I'm going to use the same formula, A of t times A sub o, which is my initial amount, times 1 plus a rate over the number of times it's compounded, to the number of times it's compounded, n times t, all right? But the difference here is I'm looking for the rate, okay? So let's plug in the information we have. I know I want to end up with $7,500, and I've initially invested $5,000. I know I have 1 plus r over. Here we got to look at how many times it's compounded, and it says compounded monthly, so that's over 12. And then I have 12 times t, which we had was 5 years. Okay, so I'm going to simplify a little bit where I can. For example, I can take this here and simplify that to 60. All right, so I have 1 plus r over 12 to the 60th power. And then here I can take this 5,000 and divide it out just like that, right? And so what that's going to end up giving me is 7,500 over 5,000, and to simplify that fraction, 1.5. So I'm going to simplify that to 1.5 here. So if you'll notice, I have to the 60th power, right? So if I want to get rid of that, I will take the 60th root of both sides, right? So now I have the 60th root of 1.5. And here in a minute, I'm going to use the calculator to type that in, because I'm going to get a really long decimal. And if I start rounding and using those decimals early, I'll end up with rounding errors at the end. So I'm going to avoid doing that if I can to the very end. So, all right, so now on to the right side, on the 60th root and the 6 to the 60th power, those cancel out. I've got 1 plus 1 over r. So then I subtract 1 from each side. So I'm going to come up here and continue. And I have 60th root of 1.5 minus 1 equals r over 12. And then I'm going to multiply 12 to both sides. 12 times the 60th root of 1.5 minus 1 equals r. And this right here is what you type into the calculator, right? So be careful here, because the 1 needs to stay outside of the square root, and the 60th root only needs to apply to the 1.5, and the 12 would need to be on the outside of that. So again, order of operations is very important. So be careful when you're typing that in, so that you don't make an error while typing it in. So what I know is r, once I do that, type it in, I know r equals 0.08137. And if I change that to a percentage, I get roughly 8.14%. All right, on the last one, I still have an interest rate question. So I have A of t equals A sub o, 1 plus r over n to the nt. All right, so it says if I invest $10,000 at a rate of 5% compounded quarterly. How long will it take to double my money? So I know if I invested 10,000, I'm going to end up with 20,000, right? Because that's doubled. Out of 1 plus 5%, so 0.05 divided by 4, and that comes from being compounded quarterly, and that's going to be to the 4t. T is our unknown. I don't know how long it will take to double my money. All right, so first thing I want to do is simplify this a little bit. I'm going to divide each side by 10,000. And that simply becomes a 2, right? This becomes a 1. So now what we have is 2 equals 1 plus 0.05 over 4 to the 4t. All right, so now if I take this number here, right? So 0.05 divided by 4 was 0.0125. And then if I take these two here and add those together, you're just going to get 1.0125. And that's the 4t power, and that's 2. From here, we got to remember this rule here. I know that b to the x equals m is going to be converted to the log base b of m equals x. Okay, so that's one way to think about it. I can simply use that conversion to rewrite that. Or the way I like to think about it is I like to say, okay, so if I take the log of 1.0125 of each side, so log of 1.0125, what ends up happening is those two are opposite operations and they cancel out. I'm left with 4t. And so then I have the log base 1.0125 of 2, and then continue with normal equation solving rules. So divide by 4, that ends up being a 1. So t actually ends up equaling this number right here. Again, I have no unknown values over there, so I simply need to take this, type it into my calculator, being careful for order of operations so that I don't make a mistake there. And what you end up getting is t is going to equal roughly 13.95. Okay, so in this particular scenario, it will take almost 14 years to double your money. So think about the answer you're getting. Compare it back to your original question. Does it make sense, right? So for example, if we want to know how long it took my money to double, right, with $10,000, and we ended up here with a number that was negative, that would make sense because I can't double my money in negative years. Nor would, for example, getting a number like 400, right? I'm not going to take 400 years to double my money. So as you're doing these, there's a real good chance that you can ask yourself, does that answer make sense to the context of the problem? That might possibly alert you to a potential mistake that you've made along the way. Okay? All right. Hope this video helps, and we'll see you in the next one.